Hi everyone. My research topic is ontology evolution using recoverable SQL logs, and my group members are my name is Awais, and my group members are Asad Mahmood, Masood Khadak, and Kifayatullah Khan. This is my outline. What is ontology? Basically, ontology is a set of concepts. They have a relationship between them, and ontology also help in synthetic and semantics of heterogeneous resources. For example, we like Awais is a student of Faz, then it's a subject, predicate, and object. Use of database logs. Why to use a ontology? Ontology is the information rich, enhance the semantics of data sources, and DB logs is the helpful to upgrade the system which queries are running on system. And we build the ontology from a DB logs. Literature reviews. These is these are the literature review in which we basically build the ontology from a different source of resources, but the major issue we are not in the major issue, they are not evolve the ontology. Similarly, in the next paper, the basically how the SQL logs are converted into the ontology. Basically, they apply the feature engineering and they did the clustering on the query. And basically, this one is a SQL log analysis in which they build the ontology. They build the basically they apply the feature engineering for regularization, and they did the query clustering. SQL to RDF. First, in the SQL to RDF, what they did, they basically make some mapping. For example, tables will be considered as a concept, and after building the mapping, they convert the basically queries into the knowledge based system. Next, our papers is belong to the ontology evolved. Basically, in with the ontology evolved, they basically evolved. Basically, they take the changes in the two ontologies and then convert into the single ontology. And then they update the ontology, both ontology, and the changes are saved in the change history logs. Research gap in the base paper. Basically, with the passage of time, data sources are evolved. Then new issues, new queries are comes we in the data sources. Find out the change in the SQL queries and evolve the ontology. Problem statements. How can we capture evolving the concept from SQL logs? Let's suppose we have a query, student select ID name from student first query, and second query is basically student ID name mark. The It's mean that the student resource are evolved. I will explain. So we have a five queries, for example, course underscore title, course dot course ID. What how we did the prefix tree, why we built the prefix tree to recover the query basically, and for the evolved ontology, I will let you know how we will update the ontology. We have a five query. Let's go select course.id, course.title. We first lowercase the query. Instead of dot, we convert to into the underscore, split them. Then basically take index 0 and 1. Check in the Bloom filter. If not evolved, then if not in the if we found that if not in the Bloom filter, then we will evolve the ontology. Otherwise, we'll not do something like for the prefix tree. How we will the prefix tree start? Our first node is start, then one, then our table name is course, as we know, and course underscore ID, course underscore title is 0 and 1. Now the next one is the basically we have a edge weight. For example, we know that 0 and 1. 0 basically course underscore id, which means the edge weight is 1, which is come only one time in the query. Now the next thing is we have a course underscore id, then the and append the list and take an index, and we did the same thing. Now the edge weight is increases. Similarly, we did same thing, and we check in the Bloom filter. If not exist, the evolve the ontology, and also increase the prefix tree. In the next step, we will do the same next in the next query, which is the student. We update the ontology student 1 2 3 4. Similarly, we will do the same thing. Here is a complete, sorry, here is a complete prefix tree building. How to recover the logs? To recover the logs, we basically we have an input is which is a start code 01. Basically, we propose the algorithm which is the rack SQL, and in which we basically our algorithm is a recursive. We start from start course, and it takes where the edge weight is increase high. For example, it doesn't matter if we go to the less weight, but we have to recover the queries because so it start course 01. Similarly, start student 2 3. We have so it's go to the where the edge weight is increased high, which is 4, so it goes this one and then it's go this one. Here is a complete step how our the query is recovered. This is our complete to complete end framework. We use a Kaggle data sets, and this is a system use experiment at we call i3 8 GB RAMs and execution. In Kaggle dataset, our time is with the passage of time. Our time in increasing the query, our the time is also increased. In the using by DFS, we have recovered the we also recover the query by DFS, but the issue is that it recovers the path only once and does not use the edge weight. So the one thing we have seen that the edge we seen that the time execution of DFS is very low, but the recovering the query from a DFS is also less. Just in the this in this example, you see that we have a 1000, we have a 1000 query. We have a basically 1000 query from our DFS. We recover 117, but our proposed algorithm recovered 822. We propose a novel idea to evolve the ontology at runtime, change the capture the change. We use a Bloom filter whether this element is exist or not. To evolve the ontology, we build the tree to recover the logs, and we can work on the join queries in the future work. Thank you. Any question? Most welcome. Here is my references and so on. Thank you, everyone.